Hey guys, welcome to lesson 14 problem set. As you can see, I am in the middle of Minecraft. But I'm actually just sitting at my desk. But I'm going to minimize this and zoom in on our screen so that we can work on lesson 14 together. Now, as always, let's get our names on this paper. And let's go ahead and read the directions so we know what to do. It says draw place value disk on the place value chart to solve, and then show each step using standard algorithm. So the first thing we need to do is take our dividend and represent that in the place value chart. So we have 4 ones, 1, 2, 3, 4. We have 2 tenths, 3 hundredths, and 6 thousandths. Again, do yourself a favor by organizing your number disk in groups or in rows of 5. That way you can easily work with them. So let me scroll down just a bit so I can see the entire place value chart. Our divisor says we're dividing by 3. Whoops. And I can see those 3 groups in my place value chart. Simply 1, 2, and 3. So I see the 3 groups that we're dividing into. And remember, we always start at the largest place value so that if we have any remaining, we can decompose them into a smaller unit and then distribute or divide there. So let's go ahead and take our dividend of 4 and 236 thousandths and divide it by our divisor of 3. And so let's just go ahead and we have 4 ones. So let's pass those out equally. 1, 2, 3. And the fourth one is going to be a remainder. So we're going to regroup those over in our tenths. 2, 3, 4, 5. Anytime we decompose, each one of our number disks is going to be regrouped as 10 of the smaller unit. So we had a remainder of 1, 1, which became 10 tenths. 10 tenths plus 2 tenths is 12 tenths. So let's go ahead, which is a multiple of 3. So I should not have any remainders, but so that was 6, 7, 8, 9, 10, 11, 12. Perfectly all used on that one. Hundredths, there's 3 of them. There's 3 groups, so I know that each group is going to get 1. And now I got thousandths, which is 6, which is a multiple of 3. I know there's 2 3s and 6. 2 groups of 3 and 6, I should say, or 3 groups of 2. And our answer, as represented in our place value chart, is what is equally in each group, which is 1 and 4 tenths, 100 2 thousandths, or 1 and 412 thousandths. Well, let's go ahead and represent these steps in the standard algorithm or the long division. So we have our dividend inside of the den, inside of the long division sign. We have our divisor on the outside. And we are going to ask ourselves, how many multiples of 3 can we take out of 4? Well, 3 groups of 1 is all we can take. 3, 6. One more group would give us 6. We subtract that 3 from the 4 ones to represent, we passed out 1 to each equal group. We've used 3, and that left us over with 1 remaining 1, just like our place value chart showed. And then we bring down our tenths. This is how we're decomposing in standard algorithm. We have now decomposed our 1 remaining 1 by bringing down the tenths and representing 12 tenths. Exactly what we started with our place value chart for tenths. We know that 12 is a multiple of 3. How many 3s is it? 3, 6, 9, 12. There's 4 groups of 3 or 3 groups of 4 inside of 12. And when we use 3 groups of 4, we used all 12 of the 12 that we were distributing, and we're left with 0 remaining tenths. Well, we have to keep dividing all the way down to our smallest place value. So now we decompose, and now we're bringing down the hundredths to work with hundredths. Well, now we're working with 3 hundredths, and that's exactly what we did in the place value chart. 3 divided by 3 How many groups? Well, that would just be 1, right? 3 groups of 1 is 3. So we subtract that from our 3, leaves us with 0 remaining hundredths. And then we decompose and bring down our 6 thousandths. And how many groups of 3 can we take out of 6? Well, 3, 6. We can take 3 groups of 2 out of 6. So we subtract that from there. We have 0 remaining. Remember, the nice thing about our place value chart, or not our place value chart, our standard algorithm is it lines everything up so nicely that we just have to make sure that the decimal follows suit and is lined up as well. All right, well, let's try that again with this problem below. Whoop, why can't I get, there it is. So let's go ahead and we're going to go a little faster on this. So let's represent 1 and 324 thousandths. And we're dividing them by 2, the divisor of 2. So I see the 2 groups in my place value chart. Now on this first one, when we're in ones, there's only 1, 1, but there's 2 groups. Can I distribute evenly to the ones if I only have 1 to give away? Nope, I can't do that evenly. If I just did 1 like that, well, there wouldn't be another 1 to give to the second group, so I can't evenly divide that. So that means I have to decompose right away into tenths. So I know that 1, 1 is 10 tenths. So 10 tenths plus the 3 tenths is 13 tenths. I now can decompose or divide, not decompose, into my tenths. So that was 10 tenths, 11 tenths, 12 tenths. And if I did that 13 tenth, it would be not equal. It would be an odd number. So that needs to be, that's our remainder, and it needs to be regrouped into hundredths. I know 1/10 is 10 hundredths. So 10 and 2 more is 12 hundredths. I know 12 is a multiple of 2. So there should not be a remainder. That was 10 of them, 11 of them, 12 of them. So we've used all of our hundredths with no remainders. And then there's 4 thousandths to divide into 2 groups. Well, again, 4 is a multiple of 2, so I know that there should be no remainders. Now to get my answer, I just look what's equally in each group. And actually, let me make that a little bit bigger to include the ones place. Well, was there anything in the ones? Nope. The decimal stays right where it's at. And there was 6 in the tenths place. There is 6 in the hundredths place. And there's 2 in the thousandths place. So our answer is going to be 0 and 662. That's how we write it. But we would say it as 0 and 662 thousandths. Okay, let's go ahead and represent that in our standard algorithm side. So here's our dividend, which is inside the den, and our divisor is 2, and it's telling us that we're trying to divide this number into 2 equal groups. So can we divide 1, 1 into 2 equal groups? Well, we showed that on the place value chart that we cannot. So we're going to represent that as a 0. Well, when we passed out 0 ones, did we pass any out? Nope. We had 2 groups of 0, which is actually 0. So 2 times 0 is 0. And we're going to subtract that. Well, we had 1 remaining 1, didn't we? Well, what did we do next? Well, we decomposed it on the place value chart to make tenths. So over on the standard algorithm, let's bring our tenths down with our remainder so that we now can see it decomposed as tenths. So now we're at 13 tenths. Well, how many multiples of 2 can we take out of 13? Well, 2, 4, 6, 8, 10, 12. I can take 6 out of that. So 2 groups of 6 out of that. When I had 2 groups of 6, I used 12 of the 13 tenths, giving me 1 remaining tenth, which we showed on the place value chart. After that, we regrouped that 1 remaining tenth as hundredths. So we're going to do that on our standard algorithm by bringing the hundredths place down. We are now working on 12 hundredths, just like we were in our place value chart. And two groups of what? How many multiples of 2 gives us 12? Well, we just did it, so it is actually 6. Two groups of 6 is 12. And when we have two groups of 6, we used all 12 of them. We have 0 remaining. Well, let's decompose it and bring down our thousandths to show us our thousandths place. Well, we're working with just 4 thousandths. How many multiples of 2 would that be? That would be 2 groups of 2. And when we had 2 groups of 2, we were left with 0 remaining. So our decimal, just make sure my decimal goes right where it's supposed to. I'm going to make sure that that's in the right place. And the answer we can see is exactly the same in both places. Great job. All right, one last practice on the back. Oh, there's 3 of them. We're just going to try these 3 because this problem set's already probably a little too long. So let's go ahead. I'm going to set these up in standard algorithm. Probably want to give yourself a little bit more room above these. All right, so I've set them up. Now I'm going to go back to the first one and try solving. So if you want to try this on your own, pause it and then zip through this part and solve it. I'm not going to take time to explain each step. I'm just going to be trying to do them to not make this video any longer than it needs to. So if we are looking at 3 as our divisor, we're looking to break this whole number, 78 hundredths, into 3 groups. So can I take the ones place, 0 ones, and divide it into 3 groups? No, there's nothing to divide, so I'm going to place the 0 above it and represent that. I cannot do that by subtracting 0 from it and then bring down my tenths. Oops, I didn't need to show the decimal. I'm just bringing down my tenths. So now I'm showing 7 tenths. How many 3s can I take out of 7 tenths? 3, 6. I can take 3 groups of 2 out of 7, which would leave me with 1 remainder. And I'm going to bring down my hundredths to represent or decompose it into hundredths. I'm now working with 18 hundredths. Well, if I know my multiples of 3, I can easily think of this, but if I have to, count on your fingers or do what you need to do, 3, 6, 9, 12, 15, 18. That's 3 groups of 6, which is 18. And if I subtract that, that gives me 0 remaining. So my answer for this answer is 0.26. Great. All right, let's keep moving. All right, our dividend is 7 28 hundredths. Our divisor is saying we're dividing it into 4 groups. So let's go ahead. Can we take our ones place, which is 7 ones, and divide that into groups of 4? Well, let's use our multiples of 4 to think of this. 4, 8. Well, I can take 1 group or 4 groups of 1 out of this number, and when I do that, I'm left with 3 remaining ones. Then I can decompose my tenths place down, and now I'm working with 32 tenths. And if we know our multiples of 4, this one should pop out at us, but if we need to, count by 4s. 4, 8, 12, 16, 20, 24, 28, 32, and that is 8 groups. So 4 groups of 8. I'm saying it backwards a lot, so I apologize. And that leaves us with 0 remaining tenths, and then we bring down our hundredths, and our hundredths are 8 hundredths. And knowing our multiples of 4, 4, 8, 4 groups of 2 gives us 8. So there's 0 remainders on this number, so our answer should be equal to 1.82. All right. Let's go to the hardest one on this paper. Our dividend is 17 45 hundredths. Our divisor is 5, saying we're dividing this into 5 groups. We start in our largest place value, which is the tens place, and we see 110. Can we distribute the tens place into 5 groups? Nope, because it's not a multiple of 5, so we can't do it. So 5, when we pass out 0 of those 10s, we represent it by saying we passed out 0 of them equally, and that left us with 1 remaining 10. We bring down our ones place to decompose it into ones. We're now working with 17. How many 5s can we take out of 17? 5, 10, 15. So we're doing 5 groups of 3, which means we've used 15 of those 17 ones equally distributed out, which leaves us with 2 remaining. Then we need to decompose our tenths place, which leaves us with 24 tenths. Let's count by 5s. 5, 10, 15, 20, 25. Well, that would be 1 too many. So let's go back to 20, which is 5 groups of 4. So 5 groups of 4 was 20. So we're going to subtract that to show how many were left over. 4 remaining tenths. So we're going to bring down our 5 thousandths. Now we're working with 45 thousandths. Well, that's a multiple of 5, isn't it? So let's see how many 5s it is. 5, 10, 15, 20, 25, 30, 35, 40, 45. So 5 groups of 9 gives us 45, which would give us 0 remaining. And our answer would be then equal to 3.49 or 3 and 49 hundredths. That was a lot of practice today, so we're not going to do the word problems. Go ahead and get to the exit ticket and do your best over there. All right, nice job.